Okay, so just a little recap what we did yesterday. So we're looking for solutions because the question says, what is a solution? So anytime you're looking for solutions, you're solving, right? So we're solving. What are we solving? Well, go back up to the top. We're solving differential equations, right? Derivative equations, we're solving them. Um, in general terms, that's with C. And in particular specific terms where they give us points, right? They give us a point. Okay. So these are the steps we've been doing, which we will continue to do. Anytime you're solving differential equations, you're going to use separation of variables. Okay. So the first thing we did was we moved everything y to the left, everything x to the right. Okay. That's the first step. If there's any constants, just keep them to the right. They're usually going to be on the right side. Just leave them there. Integrate both sides. Find the antiderivative of both sides. Okay. And then put a plus c on the right side. Don't need it on the left. Once you do that, then plug in. If you have a point, plug in, right, for x and y. And then the last step, solve for y. Okay, so those are the 4 steps. We're going to continue doing those steps. That hasn't changed. Okay, I just wanted to review before we tackled our last 2 problems. All right, so here is this guy here. Okay, so the first thing I'm going to do is rewrite it. Okay, I'm going to rewrite the problem. What is the particular solution to the differential equation with the initial condition of y0 equals 2? Okay, so this is the differential equation here. So we have dy over dx equals x squared. Okay. Okay, so we need to solve this. Separate the x's and the y's, right? We need to get the y's on the left side of the equation, the x's on the right side. Okay, well, we've done this part before. That's not a big deal. That's not anything new. So we have dy equals x squared 2y minus 1 squared dx. Okay, so now we got to get the y's on the left. We got x's on the right. Done. Y's on the left. So what are we going to do to get, how are we going to get the y's on the left? What are we going to do here? What are we going to do to get y's on the left? What's our next step, I should say? Yeah. Yeah, a lot of people would say, oh, distribute, get rid of the parentheses. Well, first of all, you can't do that because it's squared, right? We can't do that. We can only distribute when the power is 1 right there. I think the easiest thing is it's all multiplication, right? This x squared times this, right? It's all multiplication. So just do the opposite, divide. I think that's probably the easiest way. There are other ways, but this is the easiest, I think. Okay. Those cancel out to make a 1. So we get 1 over 2y minus 1 squared dy. And then over here, we're just left with x squared dx. Okay. Done. Right? Everything y related is to the right. We're with respect to y on the left. Sorry, on the left. On the right side is everything with respect to x. Step 1 done. Okay. Now our next step is to antiderivative, integrate. Okay, well, the right side's fairly not too complex, right? X squared, so we're going to add 1 to the power, divide by the new power, so it'd be 1/3, and then plus c, right? The guy on the left is a little more complex, but it's nothing you haven't done before. You just took a test where you had things like this question exactly. I think there was one on the group test, or the individual test was almost identical to that. It was a multiple choice question. What do we do to find the antiderivative of this guy? What are we going to do? We're going to have to use U substitution. Yeah, U substitution. Okay. Like I said, nothing that you haven't done, but it's a little different. Okay, so I'm over here. I'm going to have U and then du. Okay. So U, 2y minus 1. Okay. That means du is just 2. And it's not going to be dx. This one's going to be dy because everything on the left is with respect to dy. Okay. Same idea, but it's just, to be correct, it's dy. So we divide by 2 to set it equal to dy. Okay. All right, now let's go back and we're going to actually integrate. Okay, so this is 1 over u squared. Oops. Du, but then I also got to put in the 1/2, right? So the 1/2 I'm just going to put in the front because the 1/2 is just a multiplier. Okay. Okay, so if I want to integrate 1 over u squared, I have to move it to the top. So it's going to be 1/2 u to the negative 2 du. I'm not going to write the right side because it stays the same. Okay, when I'm done, I'll write it. So the right side is 1/3 x cubed plus c. You can write it, but you know it's just going to be the same thing every time. Okay, so let me integrate this guy. So we get 1/2. It's going to be u to the negative 1 divided by 1, right? But when I divide by 1, it's the same thing as multiplying by negative 1. Okay. I don't need a plus c. Don't need a plus c because I already have it on the other side. So it's going to be negative 1/2 u to the negative 1. And then u is 2y minus 1. Okay, so now I'm going to move this guy down. Okay. So negative 1 power, it's usually easier just to write it out instead of moving it to the bottom, or because negative 1 power is a little awkward. So I'm just going to move it like that. That's really what it says. Okay. Step 2 done. Integrate it, both sides. Okay. Step 3, if we have a point, plug it in. Okay, so let's go back up to the top. The point was 0, 2, 0, 2. So we're going to plug in 0 for x, 2 for y. Okay. So 1/3 0 cubed plus c. And then 2y, oops, not y. Y was 2. Okay. So the nice thing about 0 is it cancels out the left, or the right side. The right side, 0 is just going to cancel out because 0 cubed times 1/3 is just 0. So over here, we just have c. Okay, the other side, we're going to have negative, so it's going to be 2 times 3. So negative 1/6. Okay, that's C. So we're going to put that into the general solution. The general solution was right here. This is the general solution, the one with the C. So we're going to put negative 1/6 or minus 1/6 in there. Okay. All right. So let me move this guy to the top. So we have negative. Okay. All right. The last step. And like I told you guys, the last step is probably going to be the most tedious because it always is. Solve for y. Now I have a y on the left, but it's got a lot of stuff around it. Right? Y is right there. So I have to isolate it. The only thing I want on the left side of the equation is that y right there. Everything else I want gone. Question is, how do I do that, correct? How do I do that mathematically? How do I do that? How do I isolate that guy? Right? Isolate a letter. You guys have been doing that for years. Like I said, usually 6th grade they introduce that. Isolate the y. Now it's on the bottom. It's on the denominator, and it's got stuff around it. So it's a little more difficult, but not impossible. We can do it. We can only use addition, subtraction, multiplication, or division. That's all we can use, right? Really what we're just doing is undoing everything so that y is the only thing left. So what's the first thing? Yeah, you could distribute the 2. That'd be good. You don't have to, but that's certainly a first step that works. So let's distribute the 2. So we get 4y minus 2. Okay. What do we do now? What are we going to do now? How do we get y by itself? Again, this has nothing to do with calculus. This is not calculus anymore. This is more algebra, math 1 stuff. So what would you do? How would I get y by itself? Distribute it. Okay. So no more parentheses. Yeah. Okay, so multiply, but the negative, it's a binomial. Okay, so if it was this times this, I could do that. Okay. Yep, Rowan? That's that. Yeah, I agree. That's the only real step I have. Now, what is that going to do? It's going to move y to the other side. But I mean, I'm stuck. I'm behind the 8 ball here. I have nothing. I have nothing else, right? So I got to do what I got to do. Okay. So let's multiply both sides by negative. You could do both sides by positive or negative. It doesn't matter. But since it's got a negative, okay. You know what? Since I don't want to get all these, I don't want to get the signs mixed up. What I'm going to do is I'm going to move the negative up here with the -1, and I'm just going to multiply by a positive. Because I think I'm going to make a mistake if I work with a negative. So I'm going to leave the negative there. So it's going to be a -1 left there. And then I'm going to multiply this side. and that side by 4y minus 2. So that will divide to be 1. So now I have negative 1 equals 1/3 x cubed minus 1/6. And then times, so that's a binomial, times this binomial here. Okay. What do I do now? Now there's steps you could do, but we want to make sure we don't make the problem longer. We want to make the problem as short as possible, right? We don't want to make the problem longer. Like I mean, there's different ways to do it, but we want the most efficient way where we don't have to spend all day doing this problem. That's what we want. Okay. So what do you think we're going to do now? Exactly. That's what I would do. I would divide by what I don't want. I don't want this guy over here. This guy over here to the left, negative 1 or 1/3 x cubed minus 1/6. This guy right here, I don't want that, right? See, some of you might say, well, why don't you just multiply? You know, do FOIL or multiplication box, these two. That would be okay, but then you're making it to a bigger problem, because when you start mixing x's and y's, then it's going to be harder to do it that way. It's not a wrong step, right? It's not a wrong step to do first, outer, inner, last, right? And multiply it out, and you get 4 terms. It's not wrong. You can do that. But you're taking a problem and making it a little bigger, whereas this is multiplication here. It's this binomial times this binomial. So it's just easier if we divide by the binomial I don't want. Okay. If I divide by the binomial I don't want, it's a little easier. Okay. So now we have negative 1 over 1/3 x cubed minus 1/6. Now over here, it's left is 4y minus 2. Don't need parentheses anymore because it's not multiplying times anything. Now it becomes a little more clear as to what we're going to do, right? Now it's a little easier to get y by itself. So we're going to add 2. We get 4y equals negative 1. I'm going to take away the parentheses anymore. I don't need them anymore. You can have them still, but it's not needed because it's just plus 2 whole. Okay, last thing, divide by 4. So instead of dividing this whole thing by 4, what would probably be an easier way? Because now I have a fraction plus 2 divided by, so I don't want a fraction over a fraction. So what's the easier way? Instead of dividing by 4, what's the easier way of writing it on this side? But multiply by the reciprocal, yeah. So instead of dividing by 4, I would say multiply this guy by 1/4. So we get y equals 1/4 negative 1 1/3 x cubed minus 6 plus 2. Y by itself. We're done. Okay. All right. So again, the step that took us most amount of time was that last step. That's the one that'll take you the most amount of time. I'm telling you right now. That will. Luckily, it has nothing to do with calculus. So it's stuff you've already done, I should say. Okay. All right. Last question. So now we've done one with sign in it. So now we have another one with sign in it. The first one we did, the very first problem we did was dy dx equals sine of x. Okay, it's sine problem. We've done that before. Okay. So I'm going to rewrite the problem. Okay. X is on the right, y is on the left. So I'm going to multiply both sides by dx. Okay. dy equals 2 sine of x, y minus 3. Okay. X's are on the right. How do I get the y's on the left? What am I going to do to get y's on the left here? Divide by y minus 3. Exactly. Y minus 3 is not the angle. It's not sine's angle. So I can divide. The angle is x. So I can't divide by x, but this is just multiplication here. Okay. Okay. All right. So we got these guys cancel out. We got 2 sine of x dx. And over here we got y minus 3 dy. Okay. X's are on the right, y's are on the left. Step 1 done. Next step, integrate. Okay. The right side's not too bad. It's just 2 times the derivative or the antiderivative of sine. So the antiderivative of sine is negative cosine. So we need a negative sign, and then we need a cosine of x plus c. Okay. This guy here, what are we going to need to do to integrate this side? Just like the last time, we're going to have to use u substitution here. Okay. So u is going to be y minus 3. Du is going to be 1 dy, because it's with respect to y. Divide by 1, you still get 1. 1 du equals dy. Okay, so I'm going to put everything back in. So on this side, I get 1 over u du. Well, what's the antiderivative of 1 over x or 1 over u or 1 over anything? Natural log, right? Natural log, yep. So it's going to be the natural log of y minus 3. Okay. Step 2 done. Integrated both sides. Step 3, plug in x and y. Plug in x and y. X is 0, y is negative 1. X is 0, y is -1. So y is -1, x is 0. So that's why the antiderivative of natural log has absolute value bars around it. It has that because of this case right here. Because it's going to be -4. So if you went to your calculators and said, what's the natural log of -4? It would say error. Doesn't exist. That value does not exist. So instead of the natural log of 4, -4, we're going to find the natural log of regular 4. Okay. And then over here, cosine of 0 is 1. So it's -2 plus c. Okay. Now, these are going to be non-calculator questions. Didn't say anything about using a calculator or rounding or anything, so there's nothing that tells us that we're going to get to use a calculator. So what do? We leave it like that. Leave it as the natural log of 4, right? If it was the natural log of e, that's just 1. Or if it's the natural log of 1, that's 0, right? We know that one. But natural log of 4 is a decimal, 1 point something. So leave it like that, okay? Treat it like a number, because it is a number. So we're going to add 2 to both sides. The natural log of 4 plus 2 equals c. Okay, so whatever the natural log of 4 is, plus 2 is our c. So we're going to go plug that in, back up right above this, bottom of the last slide. Plug in c. So we have the natural log of y minus 3 equals -2 cosine x plus the natural log of 4 plus 2. Okay. We know what c is, so that's step 3. Okay. Again, the longest step is always going to be the last one, getting y by itself. Can I add 3 to both sides? Be done with it. Nope. Because it's just like a trig function, it's the natural log of that. So my question is, how do I get rid of a natural log? How do I how can I rewrite this so I don't have to write the natural log? Because if I don't have to write the natural log, that'll free up y. There you go. Yeah, exactly. We're going to have to change it. Right now it's written in log form. We're going to have to change it to exponential form. Okay. So real quick, going back to math 3, they go back and forth. Logs and exponentials, you can write it as a log, you can write it as an exponential. So for example, if we have log base of e, right? That's natural log of something, right? That's what we have now, right? This is the same thing as saying natural log of x, right? It's written as a log. How do I know it's written as a log? Because it has a log in it, natural log in it. So how do I change it? Just like Sebastian said, how do I change it? Well, when you're changing to an exponent, you start with the exponent and go around. So whatever the base is, that becomes the base. So as an exponent, we write the base as the big number. As a log, the base is a small number. So e is going to be a big number. The next stop is y, right? The next stop is y. After e, we get to y. That becomes the power. The last stop becomes the answer. Done. So we're going to do the same thing with the problem we have in front of us. Okay, we're going to do the same exact thing. Start with the base of the log, go from there. Okay. Well, the base is e, right? That's why it's a natural log. So we're going to start there. So I'm going to write e. And then I go to this side. This stuff right here is all going to be the exponent. This stuff right here is all going to be the exponent. Okay. First, we started with the base. First stop was this guy's the exponent. Last stop is this guy here. This guy here is what's on the other side, what it's equal to. Now I don't have to write it. I'm not going to write it with the absolute value bars. When you're doing that, you don't have to write it with the absolute value bars. When I change it over to exponential. So these two right here, these two, this guy here and this guy here, they both are the same exact thing. They both say the same exact thing. One's in log form and one's in exponential form. That's the only difference. They're just in different forms, right? It's just like, for example, decimals and fractions. I can write 1/2 as 1/2, or I can change it to a decimal, 0.5. They're both the same thing, right? That's the same thing here. They both are the same thing. They're just in different forms. Okay? And the reason I needed to do that was because I can't solve for y if I have a log attached to it. I have to get rid of that log. Okay? So now that I got rid of that, the only other step is add 3. So e to the -2 cosine x plus natural log of 4 plus 2, that's the power. Now plus 3 whole. Done. Okay, y is by itself. Done. Okay. All right. All right. So now what I'm going to do is I'm going to give you the rest of the time. You're not going to be able to finish it, but you at least maybe be able to get a couple problems done. I think it's 6 problems. 6 problems I've assigned. So at least maybe you'll be able to get 1 or 2 done. And if you have a question, you're here. You can ask questions. Okay. So if you need a Chromebook, go get a Chromebook. If you don't, it's just on your phone. It's already posted on Delta Math. Okay. I want you to get started on this. So if you have questions, because tomorrow we're going on to something new. Okay. So take a look at it. If you can do a problem or two, more than likely you're going to be okay. All right.